Now, we've been talking about the latest updates on Chandrayaan-3's progress towards the moon. We've discussed about India's aim towards the new depths with the Samudrayaan mission. And now, the nation has announced its mission to the sun. India will soon be launching its first ever space-based mission to study the surface of the sun. The spacecraft will be placed in a halo orbit in the Sun-Earth system. What will be the different objectives of the mission? And what are the specifications of this spacecraft? Well, let's get cracking into the details. While the rest of the world at this moment is focusing on the progress of the Chandrayaan-3, India has in fact announced and put out its very first image of its solar mission. The sunbound spacecraft is called Aditya L1. The mission will be the first space-based observatory by the Indian Space Agency. The spacecraft will be placed in a halo orbit around the Lagrange point 1, also known as L1. And this orbit will be about 1.5 kilometers far from the Earth. The ISRO chairman S. Somnath said that the launch will in fact take place sometime later this month, probably by the 26th of August. That's how imminent the mission to the sun is. The mission will be launched by a PSLV rocket from the Satish Dhawan Space Center. The spacecraft will be initially placed in a low Earth orbit and then will be launched towards the L1 point by a propulsion system. Let's also talk about what the spacecraft is capable of. Now, the Aditya L1's principal objective will be to study the different layers of the sun. Layers like the photosphere, the chromosphere and the outermost layer, the corona, by using electromagnetic field detectors. The spacecraft will be loaded with 7 payloads which will collect a variety of crucial information. The data is expected to reveal the problems of coronal heating, coronal mass ejection, pre-flare and flare activities, dynamics of space weather, and the propagation of particles. So how has ISRO distinguished the 7 payloads, and what does each one of them do? The first one is the visible emission line coronagraph. The payload is solely meant for studying the corona layer. It will be used for imaging spectroscopy and also for coronal mass ejections. The second is the solar ultraviolet imaging telescope. It will focus on the photosphere and the chromosphere imaging and broadband. The telescope will also measure the solar irradiance variations. And then comes the solar low energy X-ray spectrometer and the high level energy L1 orbiting X-ray spectrometer. Now, these will study the soft and the hard X-ray flares from the sun. The Aditya Solar Wind Particle Experiment and also the Plasma Analyzer package for Aditya will analyze the electrons and the protons in the explosive solar wind that continuously comes out of the sun. Lastly, the advanced triaxial high-resolution digital magnetometers will study the interplanetary magnetic field. The ISRO chairman has called the spacecraft as a space-based protector. He said, and I quote him here, Aditya L1 will keep an eye on solar flares and the ensuing solar storms. It will look at the sun continuously and hence it can forewarn us of imminent solar electromagnetic effects on Earth and thus protect our satellites and other power electricals and communication networks from getting disrupted. So as we told you about the solar mission, Chandrayaan-3 on the other hand is racing for its rendezvous with the moon's southern pole on the 23rd of August. The landing module will soon break away from the propulsion module. India is of course aiming for the moon, the sun and even the depths of the ocean, and we'll keep a watch for the latest updates. WION is now available in your country. Download the app now and get all the news on the move.